Okay, let's begin with the next topic, evaporation. Do we always need to heat or change pressure for changing the state of matter? Can we quote some examples from our daily life where change of state from liquid to vapor takes place without the liquid reaching the boiling point? Many times we have seen that water when left uncovered slowly changes into vapor. So if you take water in a bowl and place it outside or even in your room, you find that this water evaporates after some time. So why does the water evaporate on its own? Wet clothes dry up. How does this happen? Here we talk about what is evaporation. We know that particles of matter are always moving, are never at rest. At a given temperature in any gas, liquid or solid, there are particles with different amounts of kinetic energy. Means the particles present in the gas, liquid or solid, any state of matter we are talking about, possess kinetic energy, but the amount of kinetic energy each particle possesses is different. So particles have different amount of kinetic energy. In case of liquids, if we talk about water, a small fraction of particles at the surface having higher kinetic energy are able to break from the forces of attraction of other particles and get converted into vapor. So when we talk about the river bodies being heated up, it is only the water particles at the surface which absorb the heat energy from the surroundings. They are able to break the forces of attraction, and so these water particles change into the vapor state. This phenomenon of change of liquid into vapors at any temperature, this is more important, at any temperature below the boiling point is called evaporation. So you find the water evaporating from the river bodies. This is evaporation. You hang your clothes, wet clothes out in the sunshine. You find that these clothes dry up under the heat of the sun. This process is again evaporation. Now let's talk about what are the factors which affect the process of evaporation. For this one, activity is given in your book, and that activity says that you have to take 5 milliliter of water. 5 milliliter of water, take it in a test tube and you place it near a window or under a fan. Another 5 milliliter of water to be taken in the open china dish, which is a crucible, or you can even in your house take it in a bowl, right? And keep it near a window or under a fan. Another 5 milliliter of water to be taken again in the open china dish, but this time we are placing it inside the cupboard or on a shelf in the class. Record the room temperature, record the time or days taken for the evaporation process in the above cases, and repeat this activity again for the rainy day and record the observations. What we observe are these things, and these are the factors which affect the rate of evaporation, right? Let us talk about these one by one. The first one is increase in the surface area. So let us find out how surface area affects the process of evaporation. We know that evaporation is a surface phenomenon. Just now I explained, in case of the liquid particles, the particles present at the top layer absorb the heat energy from the surroundings. They are able to overcome the forces of attraction and they change their state into the vapor state. So we say evaporation is a surface phenomenon. If surface area is increased, the rate of evaporation increases. We call this as a directly proportional relationship. Means if the surface area increases, rate of evaporation increases. If the surface area decreases, rate of evaporation decreases. We have the example here. While putting clothes for drying up, right, we spread them out. So there are two ways in which we can put the clothes out. I mean, there are a number of ways, but let's just talk about these two ways. One, you take out the cloth. Let us say you're taking a bed sheet. You want to spread it out in the sunshine. So one is you spread it out onto the wire and hang it like that in the sunshine for it to dry. The other way is you fold this bed sheet, right? Remember, every time you are folding the bed sheet, you are reducing the area available for the water to evaporate. Okay, so the second is you fold the bed sheet number of times and then place it on the or hang it out in the sunshine. In which of the two cases would you find that the bed sheet dries up faster? You would observe that it is in the first case where you have spread the bed sheet completely, surface area is increased, so water evaporates fast and the bed sheet dries faster in this case, right. This thing can also be understood with the help of one more example. This example is, suppose you want to drink milk and this milk is very hot. You have taken the milk or tea in a cup, right, and the tea is very hot. You want to cool it down. So what you do is you increase the surface area. So you must have seen people putting the tea in a saucer, that is a plate, and the surface area increases. So it is easier for us to drink water as water evaporates faster from a saucer than from a cup. The surface area increases. We look at the second factor, and this factor is increase of the temperature. Again here we find that there is a directly proportional relationship, means we increase the temperature, evaporation increases, the temperature is decreased, evaporation decreases. Why this happens? With the increase of temperature, more number of particles get enough kinetic energy and they go into the vapor state. Again here, let's look at the everyday example. During the summertime, during the summer season, we find that the clothes dry faster because the temperature is more, evaporation increases. Whereas in the winters, where the temperature is comparatively less than summers, we find that the clothes take time to dry, right. Now we come to the third factor, and this is a decrease in the humidity. First of all, let's find out what is humidity. Humidity is the amount of water vapors present in the air. Okay. Now if the air is already saturated with the water vapors, already filled with the water vapors, there is no place for the water vapors to go into the atmosphere, then evaporation process would decrease. Changing of water into water vapors and those vapors going into the air which is already filled with water vapors, this entire process decreases. So more the humid air or more the water vapors in the atmosphere, less will be the process of evaporation. So we find that during the rainy season, where the air becomes more humid, the clothes take time to dry up as compared to the sunny days, right. So let's talk about this. Again here it is this relationship is called as inversely proportional relationship. Decrease in humidity increases evaporation, increase in humidity decreases evaporation, right. The fourth factor is increase in wind speed. What happens when the wind blows? What happens to the rate of evaporation? It is a common observation that clothes dry faster on a windy day. That means if the wind is blowing, the clothes will dry faster. So we say there is a direct relationship. More the speed of the wind, more will be the rate of evaporation. With the increase in wind speed, the particles of water vapors move away with the wind. So now there is more space created in the atmosphere for the water vapors to go. So evaporation process speeds up. We find this again, we can take this example from a daily life. So if you want to cool down the tea, as I was discussing the example of the tea here or the hot liquid here in the cups and the saucer, if you want to speed up this particular process also, the evaporation, you can place this saucer or the cup in under a fan also. So you switch on the fan and you find that the liquid cools down faster. Now these were the four factors. So let me summarize these four factors. One is the surface area which affects the evaporation. So more the surface area, more will be the evaporation. Second was your increase of temperature. Third was decrease in humidity. Fourth is increase in wind speed. Now we come to the next topic, and that is how does evaporation cause cooling. This is the last topic of this particular lesson, right. And we find out that in the open vessel, the liquid keeps on evaporating. Remember, evaporation is a process in which the particles changes from liquid to gaseous state at all temperatures below the boiling point. How do these particles change their state? From where do they get the energy? The particles of liquid absorb energy from the surroundings, right? And when the energy is absorbed from the surroundings, this makes the surroundings cold. So the particles of the liquid kept in the vessel takes the heat from the surroundings. As a result, the temperature of the surroundings decreases, the surroundings become cold, and so we say evaporation causes cooling. Let's look at these few application based questions here. The first is, what happens when you pour some acetone? Now acetone is nail polish remover on your palm, so you can even try this at your home. We find that a palm feels cold. Now why is that so? This is the reason. The particles gain energy from your palm or the surroundings. So they get enough energy to change their state into the vapor state, and they evaporate, causing the palm to feel cold. Another question, and that is, after a hot sunny day, people sprinkle water on the roof or open ground. Why? Because the large latent heat of vaporization of water helps to cool the hot surface. Here the answer has been given in terms of the latent heat of vaporization. You can even say that the water absorbs the heat from the hot surface, that is hot roof or the open ground, and evaporates, causing the ground or the roof to become cooler. We can take other more examples from the daily life where the effect of cooling due to evaporation is felt. For example, why should we wear cotton clothes during the summer seasons? And the answer is, during summer we perspire more, we sweat more, pasina bahut aata hai, because of the mechanism of a body which keeps us cool. During evaporation, the particles at the surface of the liquid gain energy from the surroundings or the body surface. So when the heat from the body is taken by the water, water evaporates, changes its state, and the body temperature comes down. The heat energy equal to the latent heat of vaporization is absorbed. I'll come back to this. So the heat energy equal to the latent heat of vaporization is absorbed from the body, leaving the body cool. This latent heat of vaporization is the energy required for the change of state to take place, right? Cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere. Exposing it means it is letting the sweat be exposed to the atmosphere for the evaporation process, for it to turn into the vapors. We come to another question here, and this question is, this is the last question of this particular lesson in the chapter. Why do we see water droplets on the outer surface of a glass containing ice cold water? Something that you must have seen when you bring water bottles to the school, right? You have put the ice cold water in the water bottles, and you find that it is all wet, the water bottle is all wet from the outside. Now how does it happen? Well, let's see the reason. Here we find that the water vapor present in the air on coming in contact with the cold glass of water loses energy and gets converted to the liquid state, which we see as water droplets, right? So it is the water vapors present in the surrounding air surrounding the water bottle, which contains a cold water. So when this water vapor comes in contact with the cool surface of the water bottle, it loses the energy, and when the water vapors loses energy, that is water vapors, the gaseous state, when they lose the energy, right, when they lose the heat, then they turn back into the liquid state. So we see this as the water droplets.